Good morning, good afternoon, good evening to some of you. I hope everyone is doing okay during this pandemic period and really appreciate you joining our webinar today. Looks like a great day to talk about application resilience, particularly the well architecture and application resilience. Let's wait for a couple more minutes to see if we can accommodate a few more people. Attendance is good, and let's wait for a few more minutes. Thank you for waiting. Please let me know if you are able to see my slides. It's always one of the checks that we do. Since we are all switching between all kinds of communication tools, Zoom and Google Meet, and then go to webinar, and then I tend to forget which button to click. So I hope the screen is visible. You could say yes or no on the chat room as well. It will be really appreciated. And on the right-hand side, you have access to a bunch of tools. If you're not familiar with GoToWebinar control panel, we'll be doing a couple of polls, not to bother too much, but on the right-hand side, you have access to those quick drop-downs as well. Great. Instead of wasting everyone's time, when people join, they can catch up. Otherwise, we are going to record this webinar anyway. So really appreciate all of you joining today to talk about cloud well architecture for application resilience. And we'll be going into the details of how AWS really defines well architecture for the application resilience, and other well architecture spans multiple pillars, but will be very specifically focused around the application resilience. I am Govind Rangaswamy, founder and CEO of the company called Phoenix, and we have been at it with respect to cloud application resilience for close to 5 years now, and a number of customers run our solution. As a team, we have built and sold multi-cloud management solutions before starting Phoenix. So, I can imagine like 7, 8 years ago, a few people, talk about multi-cloud at the time when the multi-cloud was all about just a private cloud and a bunch of upcoming public cloud. So as a team, we are well versed about multiple cloud architectures. And today we'll be just focusing on the AWS well architecture and why that relates to application resilience, and is there a solution, an easy solution for achieving application resilience. Anyway, when you have any sort of question, if you just raise it on the right-hand side, I will know, so I can be prepared to answer those questions appropriately. If one of my team members joined, I hope the slide is visible. If not, please let me know ahead of time. That way I can adjust it. There are 5 pillars of the AWS Well Architecture Framework. And if you look at the 5 pillars, the first and foremost is an operational excellence. You might have migrated from on-prem solutions, or you might have started off completely on AWS in terms of building the right architecture for your application. And when you think about operational excellence, it's about just running and monitoring the system to deliver the business value. So that's all they talk about. Right? Performance efficiency is another pillar of the well architecture framework, where it's about using the cloud resources efficiently in terms of right-sizing the infrastructure, or creating the load balancer to appropriately scale based on the performance requirement of the application. Right? Those are performance efficiency. It's not just about achieving performance, but efficiently achieving the performance for your applications. Third is security. I don't have to explain this. Everyone is going through in their mind every day, perhaps, about security. It's about protecting and particularly avoiding security incidents. And more importantly, even if you were involved in the security incidents, depending on the attack, you should be able to recover from that really, really quickly. So that aspect we'll cover in this particular webinar as well. Fourth is the cost optimization. Everyone is using, or I would say even binging on the cloud infrastructure, depending on the type of application, depending on the type of company. The costs are increasing on the AWS side and other clouds as well. But then think about optimizing the cost appropriately based on your performance, based on your other requirements. Again, all of these are great topics, right, across the 5 pillars of Well-Architected Framework. But we are not here to talk about all of those. We are very, very focused around the reliability of the application. Reliability means that a resilient workload, right? How fast can those workloads be recovered if there were failures of the applications running on the AWS platform? So we'll talk about just the reliability pillar, and then the reliability pillar, and you have a number of topics. In fact, the Well-Architected Framework as a tool, AWS has released a tool where you can run through all of those tests and see how well you are architected against the framework that AWS has published. In this particular one, we'll be just talking about the reliability component of it. Now, when it comes to reliability, and I will be interchangeably using resiliency and reliability, right? Reliability is the end goal, and the resiliency is something that you strive to achieve. Now, when it comes to the cloud platforms, the public cloud platforms in general, you have a shared responsibility model. So if you think about AWS, they are responsible for the resiliency of the cloud services, meaning that compute, storage, database, networking, all of that hardware, all of that services built on top of the hardware, all of that is their responsibility. They have global infrastructure, and the number of regions are growing. The availability zones within those regions are growing. And now they are adding more and more edge locations on top of the AWS outpost-based, private cloud-based outposts as well. So more and more edge locations are being added, and you could pretty much leverage all of them. On the other hand, they will take care of the resiliency of the cloud, right? But when it comes to resiliency in the cloud, this is AWS picture, by the way, as a customer, then you will have to really worry about the data security, the data backup to start with, right? Make sure that your data is properly protected. Your workload architecture, when I say workload, I'm talking about really a system consisting of multiple components. And those components are actually becoming more dynamic and are all maybe growing depending on type of applications. Then you have to worry about the change management not only from the application perspective, but also how you control the infrastructure for those applications as well, meaning that how do you really control and execute infrastructure as code if you have implemented, or the entire DevOps scenario to change the application components, application binaries, as well as infrastructure. And how do you really manage the failures across the board, right? And managing the quota and constraints, things like that. So overall, if you think about all of those components, it's basically correspond to the resiliency in the cloud for you as a customer to manage. It's your responsibility. So it's a great, responsibility, shared responsibility model that has been known for some time. As you know, AWS recently hit 15th birthday, 15. It's amazing, when I look back myself personally as a career. Now, I started off with cloud almost like 10 years ago now. So 2011 was when I got into the cloud. And I used to get up in conferences and things like that. I would talk about private cloud as a compatible cloud with AWS. There was only AWS Infrastructure API. And when you listen to AWS executive management, including Werner Vogels, he would say failures are a given, right? If not now, they will eventually fail. Right? Hardware fails, software fails. There's failure everywhere. Now, it's our responsibility as a user of the cloud to make sure that we can architect around those failures to preserve the resiliency of the application. Right? So when it comes down to the resiliency of our applications, there are criteria. So depending on the type and the tiers of the application, we'll have to decide what kind of resiliency do we want to really achieve on top of the AWS platform by leveraging, of course, all the global infrastructure, the infrastructure resiliency that they provide. It could mean that as simple as backing up and restoring the local region. In fact, it could be just the local zone restoration, or you could have a completely pilot lighted environment across another region. Sometimes, you tend to start with another zone within the region itself. And third pillar is a warm standby. If you're talking about really like a trading platform, your mission critical platform. Some of our customer applications that we have seen is like warm standby. They're ready to go. Again, the warm standby is a very interesting component where do you want to have the storage as a warm standby, or the entire environment as warm standby, or the database as a warm standby? How do you really want it? Right? And then multi-site active architectures. A lot of our customers have tried to stretch their applications beyond a particular region, the East Coast to the West Coast, or even the Central to West Coast, or Central to East Coast regions, but they have run into issues. So they have kind of scaled back that expectation, depending on the type of application, of course, to a particular region. And within the region, you can have multiple zones architected in such a way that you can perhaps achieve zero downtime or near zero downtime. So in all these cases, you will have to obviously back up your data, right? You'll have to isolate your failures of the component. So if you have distributed application, you'll have to really think about how do you really manage the failure of every one of your application components, and also the infrastructure for those application components is your responsibility. So overall, you can go ahead and read, if you search for AWS Wellarchitecture Framework, a ton of data available. Again, as mentioned, we'll just focus around application resilience for now. So the definition of application resilience, again, we simply stand on the shoulders of the giants. We leverage that same very definition that they put in. That is about a system's ability to recover from failures fast. Right? I mentioned that as a fast and bold letters. That's because it was not the expectation from the old days. The expectation around recovery times, right? The expectations around the applications always on expectations have changed as well. So people are expecting, if I'm running on AWS, and I should be able to run just like Amazon.com, which never fails, or like Netflix. That's a great expectation, but how do you really achieve it? This is an example of one of our customers that's processing $16 billion mortgage payments every quarter. And if you look at this application, this is a real life application. And in this application, there are multiple zones involved, 3 different zones, and multiple ODS components, multiple application load balances, network load balances, and a bunch of other services combined together. We looked at one of our other customers today, were like 57 different application infrastructure services involved in a particular application. I mean, this customer simply moved recently from the data center. They completely closed down the data center and moved to the cloud. And I wouldn't have imagined them using all kinds of these 50 plus instance types. I'm not talking about just a compute. Compute is just one type. Load balance is another type. RDS is another type. So the service components are increasing day by day. The distribution of the application architecture is also increasing. In that case, how do you really bring the application resilience? Right? When I talk about application resilience, there are 2 components associated with it. One is backup and DR, and how do you really back up the bare minimum table stakes, right? Got to have those bare minimums. You should be able to back up. Of course, I should be able to restore at any point in time in any region. The second is that pushing the boundary of these capabilities towards high availability, which means that I should be able to decrease my mean time between failures. Even if the failures occur, because it's given that failures will occur, if that is the case, what is the mean time between recoveries, MTTR? So how do you really kind of take it over a period of time? That is about BF and MTTR, which is the high availability component of the application resilience, right? So when you think about it, we all understand there's a shared responsibility model. That's not perfect. But the issue is that how do you really understand where the failures are coming from, right? What kind of failures? And you may be experiencing completely different type of failure. So that's why I put in one quick polling here. So if you could please take care of that, and that way I can tailor my presentation around this particular question. So if you could quickly launch that, answer these questions, what kind of failures have you experienced lately, right? Based on your applications. And if you think about applications could fail multiple ways, and your application could be completely architected in a distributed way. Some of you might have just shifted your workloads from your on-prem to AWS. If that's the case, what is your failure modes? And if I have not mentioned anything that is corresponding to your particular failure mechanisms, don't worry about it. Please let me know. That way I can quickly understand it. So this is perfect. Thank you. Really appreciate it. And if you think about it, 100% of the time, due to misconfiguration, I mean, you are not alone. More than 50% of the cloud ops people are experiencing unbelievable number of more than 50 times. And I have another information. I think you might have seen it on the LinkedIn post and things like that. People experience failures because of the misconfigurations, right? And bad deployments contributes 1/3. Ransomware attacks. So the failures are real, right? Let me call that close the poll. Thank you very much for that. And if that is the case, when you think about it, it is not just lost revenue situation. It is the damaged reputation. If it is a ransomware attack, it's a damaged reputation problem. And then you put in lots of precious engineering time and resources to fix those issues. That is another crazy thing that you will end up getting into, right? And that's when you realize what tools can help. And then we automatically default to this, known quantities like VM backup and restore. We have all known, at least I have known for a long time. I've been in this industry for a long time, and then backup and restore is like a basic component of this tool set. And I can improve the RTO and perhaps the RPO, right, by doing some kind of a host replication. And if you're using RDS, for example, you can spread between two different zones and you can achieve near zero data loss. But what happens when the configurations change? And then suddenly you are now in a position to recover only that particular component of your workload or the system, right? Or the entire thing. And third, people tend to use cloud storage snapshots. Totally fine. Because if none of these old solutions work, you could at least start with storage snapshots. And then you start writing the manual recovery scripts and so on. And that's when you realize that, the existing systems fall short of their expectation. One, they cannot discover and understand, analyze the resiliency issues. What is really protected? Is my security group really protected? Can I go back in time? Right? Third, there's no point in putting a proprietary data management system on top of the cloud management, right? So you have the infrastructure running completely utilized for distributed application like the one that I showed you before. And now if you have to put in a data management system to pull the data and fill up the data management system in itself is a problem. And how do you really kind of go about doing that? And likewise, you can see number of different problems. And then how do you really utilize these systems to recover your applications, right? And that is when, if there is an easy solution. I mean, again, Appranix gives you one type of solution. That could be a mechanism in which you could leverage the cloud built-in capabilities to come up with one of those solutions, or combine multiple tools to do that. Again, the idea of this webinar is not only just to highlight what is available from an Appranix point of view, but also make sure that you are aware of other possibilities, right? That way, you can at least, put a goal, towards achieving a better resiliency than what you could do yesterday, which is like, even if it is 1%, over a period of 1 year, you improve by 33%, right? Which is great. So we offer one of those solutions. And that is actually much easier to think about. So, you can go to AWS Marketplace and look at, you just search for AWS and Pranix on Google, you will get to that AWS Marketplace and you can subscribe. And you can achieve over a coffee break the entire resiliency that we are talking about, at least 3 to 4 components that we highlighted as part of the application resiliency can be achieved over a coffee break. And of course, the assumption here is that you do have permission to buy the services over the marketplace. The billing and everything is associated. So let's set aside those application requirements. So, once you give the permissions, you are in, you can pretty much launch and protect. Even if you have started taking snapshots, our system will pick it up from there and build a nice application environment time machine. So think about it. Your application environment could be as simple as this. I'm talking about this simple one because this is about 175 instances, various instances, and I'm not even talking about all other associated services here and the configuration, the dependencies. And this is about 14,000 lines of code, cloud formation code backended with this. So now you think about it, Pranix helps you build automatically. Everything is completely automated. An application environment time machine. I think it is self-explanatory. What that means is that Pranix automatically and continuously discovers your application environment, depending on the permission that you have read-only, completely agentless, complete environment metadata backup and recovery is taken care of. All the network services backup and DR is provided as well. And the core component of it is the ability to manage cloud data appropriately based on the policies that you put in. So not only just using the policies to manage the life cycle, but also it has to be forever incremental. You don't want to make full copies every weekend, right? You make one full copy once, call it as golden or whatever, and after that you simply make incremental copies of all the data, fully utilizing all the built-in AWS capabilities. So if you're using RDS, we leverage RDS. If you're using EFS, we leverage EFS built-in capabilities. If you're using EC2, of course, we leverage all the backend EC2 capabilities. And likewise, if you're using Kubernetes engine, it's the same thing. We leverage the built-in AWS capabilities and we manage all other components of the resiliency automatically. And at any point in time, if you want to recover, the system knows how to recover those resources because it knows the dependencies all the time. So think about it, right? Knowing the dependency of the system is like 80% of the problem. You have to know where to plug in the new system that is coming in, new EC2 coming in, new EFS system coming in, new containers coming in, right? Unless you know the dependency and the size and the configuration and the metadata, even if you try to run your infrastructure as code, it's going to simply come out and say that, sorry, there was some problem, right? That's all you will know. But how do you really make sure that you can recover? And not only that, you should be able to really leverage our capabilities to pretty much automate the simulations, recovery simulations. Believe it or not, one of our customers ran the 5th DR test last weekend in the last 4 months, right? And one of the recovery tests was on a Monday morning. Believe it or not, it was crazy enough to do a Monday morning DR test. We are not even talking about old style DR test at all. We are talking about resiliency simulations. So I have a number of use cases here, may be applicable, may not be applicable. So may I request you to just quickly see if you could fill up this particular one as well. So can use this type of capabilities to increase your application resiliency. In the case where you want to simply back up for compliance reasons, or you want to just get back that's totally fine. Or you want to do frequent DR tests, right? Or you want to do chaos engineering. Chaos engineering, I call this a production twin. This is a new concept we are pushing. It's nothing new. It's basically differentiating from what was not possible before. Chaos engineering is a great one. I realized that I misspelled it. I apologize. Chaos allows you to inject failures and see if your systems can withstand, right? And in order to do that, if you're Netflix, if you architected your application like Netflix, that's perfect, right? That's totally fine. You can inject the failure because they released Chaos Monkey to check if the system is able to recover from a failure, a known injection of the failure. That's totally fine. But if you have not architected that way, then the next potential situation could be, can I make complete production twin of my production environment? Just imagine that. If I can take the entire application environment, just like the one that I showed you before, take a copy of it, completely bring up that entire environment to another region. I don't want to even touch my production region at all. Completely separated in a different VPC and run through all kinds of failure injections there, and to a point where I'm comfortable 80 to 90% of the time, then you can run those same failure scenarios in your production environment, right? So that is also possible. Now, several ways you can leverage a system to not only just to back up. That's like basic, I would call this a resiliency 0 level, right? Level 0 resiliency, and then level 1, level 2, level 3, level 4. We have defined at some point in level 5 resiliency, completely going after a different cloud as well, right? Depending on the application type. So let me close this poll. Thank you very much for that. And I know we are hitting halfway through the webinar. What I'm going to do now is to show you what is possible in real life. So in order to do that, you can go to AWS Marketplace or AWS Business Continuity. We are one of the only 3 providers on the business continuity side on the AWS Marketplace, and you can get started right from there. Or you go to simply search on Google AWS and Appranix, and you can click that link to get to the application resilience page. So with that, let me see if there are any more questions. Otherwise, let's get to a demo. We'll open up the demo part, questions part later on again. For that, let's bring it up here. So here, like I mentioned, let me just walk you through a couple of points that you could improve your resiliency by. So when you look at the reliability pillar within the Well Architecture tool, you have 3 different data points that I would like to just consider for you. You type in a well architected, I pretty much leveraged the information from here because you are running on top of AWS and you can pretty much go through all the details. I simply highlighted some of the key components of this Well Architecture Framework. There is tremendous amount of data and information available you could go through. And for disaster recovery, you can see the resiliency means these components. So given that, you can get started with AWS Appranix, right? It is that simple. If you want to really quickly understand what's possible, and then decide what to do for your applications. So when you subscribe, you will get an email. Everything is built into AWS Marketplace, so you don't have to worry about billing and all of that. It's already taken care of, no procurement, none of that. You simply go and you'll be pointed to, once you log in, you'll be pointed to Cloud Connections page. There won't be any Cloud Connections information here, so you'll be prompted to add a Cloud connection. At that, you can say resiliency webinar connection, right? Name it appropriately, and select AWS role-based access control. So we have gone through the security certification for the enterprise, and that's the reason why we are there on the business continuity side. And select your primary region. You select region. In this particular case, we are running on the East Coast, and you can recover on the West Coast. Not only that, but also you can push it to another region of the West Coast, or you can completely go to different regions as well. Totally fine. Just imagine these possibilities, right? If you're coming particularly from the on-prem world, just by selecting that button, you can add another region. Now, underneath every one of these services, we continue to add more and more services. Within RDS, you have all the RDS coverage, all the complex RDS coverage, and some of our customers use all the 4, including Aurora is covered, by the way, in there. And you simply click next. The cloud formation template will be created and run. And you simply launch that in the console. It will automatically make sure that the permissions are given appropriately to Appranix, so that we can discover all your resources. Again, read only. There are tiers of permissions that you can give depending on how comfortable you are, but it is no more than now a managed service provider taking a look at it, or your one of your administrators taking a look at it. It's simply that. And in terms of encryption, we don't take your data, right? Appranix doesn't take your application data. Appranix only takes the metadata of your application environment configurations. Everything else is managed right within your AWS account. So we don't have a clue about your application. We only look at your application environment. Now, once you do that, if you look at the cloud connection overall, let's look at the cloud connection here. You will see the discovery end up with all kinds of information. So when you have configured to discover all of this, and depending on your environment, even though there are 11 compute instances, you can see the number of resources that are discovered here. So if you go into the load balancer, application load balancer, you'll see the information here. The real environment is running right here. So if you go to EC2 here on the East Coast, on the Virginia side, the number of instances running. And if you look at the load balancers here, multiple load balancers, these are the ones that we discovered, external and internal load balancers. The load balancers have all kinds of configurations. All the listeners are automatically configured, so you can go in and check all the configurations and listeners. This is the most complex one of those, right? So if you look at the rules, bunch of rules already edited, right? And those rules might change depending on how you configured, and your infrastructure folks might be configuring them, your SIs might be configuring them, your application and developers might be configuring them, right? And same as and the internet gateway. So if you go to the VPC dashboard, you'll see a number of resources. These VPC services, I counted, like yesterday I was sitting and counting that it's like 27 different services just on the VPC side alone, right? They keep adding the new ones. Network circles, I think these refresh for these old ones. And the DNS firewalls are new, clearly. And network firewalls are new as of last AWS reInvent. They announced these firewalls. So, depending on the scenario, depending on the type of application, you might end up leveraging a lot of these services, built-in services, right? And make sure that those services are properly configured. And that is an expectation, not necessarily can be implemented in practical life. So those configurations might be changing. This is why the cloud misconfiguration happens in the backend. Understandably so, right? And it's difficult to really keep up with those changes all the time. Now, when your application runs this way, how do you really protect that application environment as a whole? How do I protect the route tables? The route table has all kinds of configurations, right? And the dependencies, route tables do not exist, and so on. You have configurations within the VPC, maybe connected to your gateways, right? And and then multiple gateways, not only just one gateway. If you look at the gateways, and those gateways, understandably, are complex enough to provide the services necessary, but you make sure that you configure them properly with maybe infrastructure as code. If not, you might just get into the console and change it. You're free to change your production environments the way you like it, the way you have been operating. We do not ask you to change anything in your production environment. you continue to do what you do best in terms of changing the configuration to make sure your applications run to begin with. Our responsibility is to make sure that we can provide the resiliency necessary for your application environment. So this application environment can be represented what we call as an cloud assembly. Cloud assemblies are a very simple concept, right? You click cloud assembly, you provide the name, select the policies. That's all you have to do, nothing else in terms of the policies that you configure to do in terms of protection. Now, if you go into the resources themselves, if you look at the load balances, the load balances are in external and internal load balances and the network load balances that you have. In fact, the graphical view is kind of a quick one. All other components are automatically discovered. All you have to do is to look at just the top level compute. That is all you have to select. In fact, you don't have to manually select at all. All you can do is that you simply say, these are the tags that are associated with those compute. So let's say today you might have 7 compute instances, and tomorrow or an hour after, your load balancer might spin up additional 15, depending on the performance that is required by the front end of your application components. If that's the case, how do you really protect them? This is another complexity, right? With a traditional model where you will have to put an agent on every one of these compute to protect that particular compute. And by the time the protection happens, the protection and the instance itself has been evacuated, right? Completely killed off by the load balancer or the auto scaling component of it, right? So how do you really protect this? The only way to protect is to leverage what is AWS gives you in terms of capabilities to protect. So we fully leverage those snapshot capabilities, the cross-region replication capabilities, right? That way, it's all incremental. So even if it changes within a minute, no problem, because the incremental snapshots are really, really fast. It's forever incremental. So even if you have multiple terabytes, not a problem. We onboarded a customer with 175 terabytes in under 15 minutes because we didn't have to move the data, right? So you simply select those instances. Everything else will be automatically calculated, identified, dependencies-wise by Appranix, and your responsibility is to simply add your policies. Now you can say daily, weekly policies, and you add number of policies in addition to whatever the policies that you have. Again, every one of these additional policies will build on top of what you already have. So they are only adding additional incremental snapshot. That was all like really, really fast. And as I mentioned before, Appranix builds an application environment time machine. This looks so innocent until you click. So if you go in, all of that information at a particular point in time, an hour ago, will be captured and processed by Appranix. So if you look at the network load balancer configuration, if you go in there, all these configurations are captured as of an hour ago. Let's go back in time and look at the policies here, look at a weekly policy, and look at the timeline. As of a week ago, we have captured everything. So every time you put the policy in, it only took 4 minutes. So this is a very simple application. Even if it's a very large application, we have seen all the information getting captured based on the policies. The environment that I showed you, they have captured for every 3 hours. Now, just imagine if you are misconfiguring your environments. Wouldn't you love to have a capability to go back in time and look at the configuration, what my security group was 1 week ago, right? And compare, even if I have to change it. You don't have to use Appranix to realize it, but having the capability to go back in time to look at what was the latest misconfiguration which really caused the trouble is already built in. It's a fundamental resiliency built-in block, isn't it? And let's say you completely misconfigured, completely messed up the environment, ransomware attack happened. Now you are in a bind to go and recover the entire application environment, at least to borrow some time so that you can repair their production environment. If that's the case, how do you really do it? You can do it by using, if you're using iPad, go and simply touch that. So let's call it as a resiliency webinar recovery, right? You can recover in the same region, entire assembly, specific resources, just like a backup recovery system, right? And we again want you because we know the dependencies. You might be already running a compute with the same IP. So we will warn you that is the case. Or you can recover completely, cancel that, entire assembly as well. All the assembly with entire application in mind, which means that all my instances, all my load balances, all my internet gateways, entire VPC, all of that can be recovered in the same region. And you can configure. You can create a new VPC and put it in different zones. That's totally fine. Let's push the boundary to completely a different region. And if you have configured only one additional region, it will simply fill that up, saving even that time for you. Otherwise, it will give you options to recover. And you can fire up multiple recoveries. It will create new VPCs appropriately given within the quota. If you exceeded the quota, then you'll have to simply raise a support ticket. That's all you have to do. Now, you can recover using tags, specific resources, the target region. Guess what? There is no IP conflict here, right? Because it's completely in a different region, completely in a different VPC. So let's push it entire assembly. Simply click recovery. Here is the cost optimization solution. When you recover, appliance obviously has to create all the resources necessary. It's almost like the pilot light type of situation. So if you want to achieve a necessary kind of a compromise, the backup and so low RPO, RTA, this is all fine. This is reasonable. Everyone expects that. Pilot light is another one. You can just keep it running, minimum component of it. That's lower cost. Or warm standby. So Appranix pretty much pushes this. And then you might have architected for active for some of your application components. So even if you have active multi-regional load balanced application, which is completely distributed, just like what I showed you before, right? This one is like that. You can pretty much recover that as almost like a warm standby, right? So let's do that. This is a warm standby operation, right? So I can recreate everything else other than the storage that is already copied and kept as part of the replication management by Appranix. So we take care of all of that. We work around the quota limits in the number of instances that you can copy at a particular point in time. All of the life cycle is taken care of. Now, if you're just doing a test, DR test, wouldn't it be nicer if you just enabled this automatic reset, right? So that even if you forgot, let's say if you fired off a recovery over the weekend and you had to run off to get something, you completely forgot what really happened. Totally fine. You simply touch that button, right? Appranix will clean up everything that it created automatically without affecting your environment. Even if you did that in your primary production region, we'll completely isolate it. We know what we recovered. We know the dependencies. We won't touch your existing environments. So if you look at the recoveries and you look at the details, you don't have to do anything other than just clicking the button. So it will give you what is overall recovery time. And if you have configured the recoveries simulation policy, so if you go to the policies, we'll come back to this particular one. If you go to the assembly, and if you look at the policies for this assembly, and you can actually turn on recovery simulation policies. So if you go into the recovery simulation policy, weekly recovery simulations, put in a weekly on a Sunday at 12 a.m., run the recovery based on the latest timeline on the West Coast and clean up after 1 hour. Isn't it great? I mean, you simply fill up these, the system automatically takes care of recovering your environment. Now, the recovery started. Now, let's go back to the target region, which is the California region where we are trying to recover. Go to the target region. And if you look at the stacks that are being created here, resiliency, webinar, recovery, right? And if you go into the resources, the type of resources that is getting created is DHCP options. Who would have imagined there is something called DHCP options that you will have to really create in order to get your application back up and running? It's not just a bunch of instances. Of course, you have to recreate those instances. That's all totally fine. The rest is as important or more important for the recovery, right? All of that. So if you go back and look at what really is happening on the template side, right? Again, we are fully leveraging all the cloud built-in capabilities. This is the beauty of it. There's no way we can throw as many resources from our cloud to recreate your environment, right? Unless we leverage the cloud built-in capabilities so that AWS can automatically allocate number of resources for recovering your application components. So in this particular case, the number of lines of code written by Pranix will amount to about 1,300. It's not a big deal. We have seen 14,000 lines of code in one of the DR, simple DR test, right? So when you think about that kind of a thing, that kind of a recovery model, you have to think about the dependencies of it, right? How do you know the dependencies? Even if you are an SRE, really managing your application components day in, day out, it's very difficult to keep up with the configuration changes. If you're a backup and DR admin, if you are managing the entire set of applications across the board for your company, then think about that complexity, right? The number of configurations that you will have to do, which means that you should be, first of all, certified across multiple services on AWS, and you have to keep refreshing that certification, by the way. So that's about just getting the certification. How do you really put it in practice in your production environment? You have the confidence to do that, right? And that's where the resiliency service is very, very key, right? All of that automatically created, leveraged completely by Pranix, all the built-in capabilities of AWS. So if you look at the Cloud Assembly now, if you look at what's really recovered, so if you go in, the recovery is almost getting complete. You can see the number of resources recovered. So 51 of it. Recovery duration is about 4 minutes, right? 4 minutes, and the reset is pending, right? You can pretty much click to kind of reset, but the recover components as of a week ago. So we recovered the weekly recovery about the 11th of it, not completely going back completely last week. My policies are a little bit less because I'm putting my credit card, right? So if you think about it, the load balancers have listeners. Who is going to recover those listeners? Security groups, not just the security group, but also the security group ingress, egress, subnet route table association. I mean, I don't know what that really means. It's just, for me, it's a service instance, and I should now know what that really means, which means that I should know all my configurations for the security group as of the 11th. And then I also need to know all the tags. Who is going to bring up all the tags? So if I'm bringing up a production environment completely on the West Coast, how do you really connect your hub management stations or a bunch of tools that you might have put in the Cloud Hub to manage your environment? They are all going after the tags. So if you don't have the tags properly captured and recreated, the now new production environment running on the California region doesn't have a mechanism to manage, right? So that has to be taken care of as well. All of that with that single touch of the button. And if I want to, finish and get rid of that environment, it's totally fine. So I can reset it or download the template. If you look at the template, some people are asking, "Can I get that template, please?" Yes, you can. Right? You can pretty much. This is not beautifully formatted, but you can see all the dependencies are built in. Or I can go and reset. Right? Even though I set it at an hour later, you can just simply reset. That's simple. So let me see if there are questions here. Any questions? Any thoughts? Thank you for your participation, by the way. And even if you have question that you're not able to kind of wrap around based on so much information that we have given right now, I will. Okay, Paul, thank you. Yes, very impressive. It's a functionality available across all clouds. All clouds meaning 3 big clouds, AWS, Azure, and Google for now. IBM Cloud, not yet, Paul. If there are customers, we can support it. By the way, OpenShift is supported. We work with your Red Hat brethren day in, day out. OpenShift is supported across all clouds. Right. Good question. Any other thoughts? Again, it's very, very easy to get started. We have our customer success team that will love to kind of help you in terms of if you want to quickly do some kind of a POC or anything, please do not hesitate to reach out. And and you can do the self-service one. You simply go to AWS Marketplace, search for Appranix, and you can get started. Right? How do you handle customers who have migrated to the cloud but not completely utilizing fully cloud native? Not a problem. So if you have just migrated, most likely your customers are simply dumping all the instances in one of the zones of the cloud, right? One of the zones in a particular region of AWS. And then they tend to slowly refactor those application components. Perfectly suitable. So all you have to do is to just go to that AWS account and purchase Appranix trial basis. Let us know if you want to run a longer term trial. Totally fine. All you have to send is an email to us, and that way we can turn off the utilization information going automatically to AWS, right? And your licenses will not start, your consumption will not start unless you protected the environment. If you just discovered to identify how your environment's totally fine, you can go onto it. So Paul, if your customers migrated and they are just running, they're just getting started on AWS, another way customers actually leverage is that use Appranix to get this cloud formation automatically created, by the way. Right? When you move, when you migrate, when you lift and shift, you don't typically go and create cloud formation templates. You write some kind of a Terraform, download the existing Terraform to create the VPC or cloud formation template. You create the VPC, and after that, everything is kind of manual, right? Typically, that's a scenario with enterprises because they are in a fast track to move as many workloads as possible onto the AWS environments, and then slowly expand from there. So they might have kind of lost the opportunity to write that cloud formation. Because once you start your production environment, right, the production environment is running. There's no way to disrupt it. Even if you wrote the entire cloud formation, it becomes really difficult to relaunch your production environment, right? And that becomes the hardest part for cloud ops people. And even if you are managing a particular or set of services as an SRE, site reliability engineer, then you can potentially write it, but you'll have to recreate all of that. You'll have to know the configuration. So people leverage it for multiple purposes. Discover, get the cloud formation, great, thank you, Mr. Appranix, not a problem, right? We could have launched that as a free service. We didn't have time to launch that as a free service, which means that we'll have to do a bunch of work on the AWS Marketplace side. So, but that is free to use. Go ahead and use it. We'll not charge, and have fun with it, right? Any other question? Great questions, by the way. Great. So really appreciate your time Thank you for answering the poll questions as well. We'll record the entire webinar and post it on YouTube. That way, if you have your colleagues that could not attend today, you can simply forward that information. Even if you have to go back and watch it again, free to go. And please, if you get your chance, just flag it on the social media. Really appreciate that as well. Thank you very much. Have a great day.